I'll just put x. For 10 less than equal to x less than equal to, did I say 3? I meant 13. Don't know why I said 3. Okay. So that means if your f of x is greater than or equal to your g of x, then we also know that the integral of f of x from 10 to 13 is greater than or equal to your integral of g of x. Or in other words, your f is greater than or equal to your g. Okay, so we know that A is true. Okay. So we don't even have to work out B because we already know if A is true, then B has to be false. So B is false since A is true. Okay. The only way both would be true is if they were equal. Okay.
So how do you, sorry.
Oh, no problem.
Confused. How did you figure that it was true again?
Oh, this one?
Yeah.
Oh, because we have our function f of x, which was here. Oh, bring that down some. And we have our g of x, which is here.
Right.
So we know that every x value between 10 and 13 will make this one bigger than this one. Okay. So if our f of x is bigger than our g of x, then by this property here, the integral of f of x is bigger than the integral of g of x. So we knew the integral of this one would be bigger than the integral of 6x squared plus 5, which from the very beginning is just our f and our g.
So say for instance, instead of 7, that was 3. That would all be false because now that would be.
Oh yeah, if that would have been 3x squared, then this would have been less than that one. So then that one, B, would have been true if that was the case. Yeah.
Oh, I just.
Yep.
Well, answers C and D, do those come into play, or are they kind of like out of range, I guess you could say?
No, they actually do, but you have to do a little bit of assuming in a way, and I'll show you how to do those.
That's only because the x is squared is the reason why that's true.
Oh yeah. Well, even if it wasn't squared, it would still be true between 10 and 13, because if you plug in x equals 10 and x equals 13, it would still be true.
Yeah.
So as long as they're both the same, like for instance, if that said 7x plus 3 versus 6x squared, then it would be false. Or,
Yep, then it would be false.
Or it'd still be true if it was 7x squared versus just 6x plus 5.
Yep, that would be true.
Okay.
Yep. So if you had something like 7x squared plus 3 is greater than or equal to 6x squared plus 3, it would still be true, but if you changed your integral from 0 to, say, 0 to 2, then it would be equal if x was 0. So as long as you have that equal to, it would have still been true, but if that would have just been greater than, you would have had two equal values at 0, so it would have been false.
So there's a like if let's say that there was both of them were plus 5, and then your range was from 0 to 12 or whatever. That means you can actually have both A and B be true as well.
Only if they were both equal.
Yeah. If
Yeah.
They were.
Oh yeah, if they were both equal. So if you had 7x squared plus 3 here, and if you had 7x squared, well, it would have to be plus 3 here. That was the only way both could be equal. So if they were both 7x squared plus 3, then this one and this one will both be true.
What I'm saying, if one was 7x squared plus 5,
Mhm.
the other one is 6x squared plus 5, but then your range is from 0 to 12. Technically, if you put with 0 in there, they're both true.
Only at 0.
Yeah.
But then after that,
Yeah.
they
after
would
that,
be different.
So would the answer be, it would be partly true? I mean,
It would be true for both, wouldn't it?
Well,
If
that's
that
what I'm
answer,
saying.
because at least at one part, it was true.
Just for one value of x. Remember, it has to be
But
for
when you-
the
but when-
entire interval.
When the question is based on what we were given,
Mm-hmm.
let's say the same question,
Mhm.
and it doesn't say what value, so you would state that A and B is true, or would you just say only A and B is true only if it was 0?
Well, if it's just for one value in the interval, then it wouldn't have been true. It would have to be for every value
Okay.
between A and B.
Okay.
Yep, that's why we had to count from 10 to 13.
The only answer is A though for this one?
Yep, just, well, so far.
Oh,
So we still have to do C and D.
answer
Oh.
A and B, right?
So the answer is A is true and B is false.
Yep, B is false.
I'm saying and doing that answers A and B because of that. That's what I was getting at.
If we did that complicated, like, they're both equaling to each other or at one interval or whatnot, I think it's something else.
Yep, like I said, only if they're completely equal. That's the only time they will both be true.
No, never mind.
All right, so I think I'll do C on the next page.
Moving down a little.
Oh, sorry about that. Okay, so for C, we want to know if f is less than or equal to 9. First, let's just let f equal 9. Okay, we'll see about the less than afterwards. Okay, so that means the integral from 10 to 13 of 7x squared plus 3 with respect to x is equal to 9. Okay. So here, remember, that's just the area up underneath the function. Okay. So area under 7x squared plus 3. Okay, so that's our integral. It just tells us the area underneath there. Okay.
You just do 7x plus 3 equals 9 and then solve for x, correct?
Oh, no, you don't even have to do that.
Oh, okay.
Oh, no, good idea, though. Okay, so we know that we're going from 10 to 13. So we have our A equals 10, and our B is 13. That means the length of x is 3. Just going from 10 to 13.
The width or length? You just said length.
Width.
Okay.
Yep. So we have our width, and let's just kind of imagine we have just that one rectangle underneath that function. So if we have that one rectangle, then our area is going to be length times width. So if we have that 1, length times width, if we have one rectangle. Okay, we know we're not going to have one, but let's just say we started with just one rectangle.
how is rectangle?
Hmm?
I didn't know you were using a rectangle.
Oh, because it's a quadratic
Square.
function.
Oh.
Yeah. Plus, we integrate it, it becomes a cubic function, which
Okay.
kind of throws it off. All right, so if we assume we have just one rectangle to measure the integral, that means that, where is it? Our y, let me see, that says a width of 3. So our y, which is our f of x, would have to be 3 also. Because if our width is 3 and our length would have to be 3 for our area to be 9. So it would have to be 3 also for the area to be 9. Okay, so we have an x equals 3 and y equals 3, or I might as well say f of x equals 3. Okay, so if f of x is equal to 3, that means your 7x squared plus 3 is equal to 3. Okay, so the integral from 10 to 13, 7x squared plus 3 with respect to x, remember that's your f of x. And that would be the integral from 10 to 13 of 3 with respect to x. Okay, so we can tell by looking at it, between 10 and 13, this would actually be bigger than this. Okay, so really instead of equal to, it's greater than or equal to. But you really don't need the equal to, because
Can I
between...
look at it simpler?
Mhm.
And can you just look at the f of 9, or f is less than or equal to 9, and because 9 is not within the 10 to 13? Is that completely wrong to look at it like that? Like so simple?
You're kind of skipped to my next step, but yep, you pretty much have the same idea. Because remember...
So you're just looking at the range, basically.
Exactly. So here, since you have your f of x here, this is your f. But it's greater than or equal to, remember this, we know that's equal to 9. So I think that's what you were saying.
No, I'm just looking at the, from 10 to 13.
Mm-hmm.
I'm just going in my mind from 10 to 13, those, like 9's not even in that. Going from 10, 11, 12, 13, 9 is not.
Oh, no, not even in it.
Oh, okay. I was trying to, maybe I'm thinking too simple, or
No, no.
trying to cheat
Well,
too
then
much.
let's just take the answer where it would be minus a, so it could technically. If you were to solve the integral, at least.
Oh, if you were to solve it out, this
Oh,
would
well,
still
B
be,
minus A,
yeah,
yeah.
yeah, this would still be true. Okay, so remember, this is for C. This is actually false, since we were actually looking for C f less than or equal to 9. That's what we were looking to prove, but we ended up proving the opposite. I actually could have worded that a little bit different. Just say this is false. So it's not as confusing of a statement. All right, so any questions on that one?
So, in order for that to be true, like, you said x would have to be 9, or in order for the area to equal 9,
Mm-hmm. Well, we know our width is 3, because that's the distance between 10 and 13. So if our width, because remember, if you're looking at the x-axis, between 10 and 13 would give you a width of 3. Oh, sorry. Yep, so between 10 and 13 would give you a width of 3. So now we're just looking for our length. But if we have a rectangle and our width is 3, our length would have to be 3 if our integral, which just tells us the area, is 9.
So we know because of the range, we know that the width is 3.
Yes.
Because of the range.
Yep, exactly.
Okay. And so because of the range,
Mm-hmm.
length times width,
Mm-hmm.
in order for that to find the area to equal 9,
Mm-hmm.
it has to be 3.
Yep, it has to be 3. That's the only way your area will equal 9.
Okay. In order for that, at least that to be true.
Mm-hmm.
Now, my question goes into, and I hate to be repetitive,
Mhm.
but again, how do you realize that that is false just because that, I mean, that is, okay, so we're looking for f is less than 9.
Yeah, exactly.
And we proved that f would be
Greater than or equal to 9. Yep,
Okay.
that's it.
That's, all right.
All right, does that make sense? Okay. Yeah.
To be more complicated, what would happen if we were to assume that there were like more than one rectangles? It would just still have to be, the width will ultimately equal 3 or around.
Oh yeah, the width would still equal 3. So if you made it, say if you assumed more rectangles, then now you'd have to find the length of the first rectangle, the second rectangle, the third rectangle, and
But for the
so
most
forth
part,
and so on. That's why it's easier to assume you're working with just one rectangle, because you don't have to do all of that. All right. So any other questions on that one? Yes.
So like, what exactly is f then if it's greater than 9? What exactly is it then? The value?
Oh, this is just saying that this integral will always be greater than or equal to 9 with this interval right here.
So you're plugging in you'd be plugging in the values from 10 to 13 then, and then that would give you a number that would be greater than 9.
Yep, exactly. Yep. So any value between 10 and 13, that integral is going to be bigger than 9.
So we could just technically try out all three of those in the equation, 10, 11, 12, 13, if you're real desperate.
Well, the thing is, if
Find
you
out which
did
one's
that,
greater than 9.
you would prove it's true for 10, 11, 12, and 13. What about 10.5? What about 10.8?
Oh,
What about
man.
these? You have to prove it's true for every value in
You can't
between.
just let it simplify.
And that's the one thing, you're proving it for just a few. If you can prove it for all of them, then that's why you're doing this step. I know math is kind of irritating like that. But that's what makes it fun. All right. Any other questions on this one? All right. And for D, we'll actually solve D the same way we solved C. Okay. Remember, we want to prove that G is greater than or equal to 15. So we'll let G equal 15. And remember, we're starting with the integral from 10 to 13 of 6x squared plus 5 with respect to x. That's our G, so we're going to make that equal 15. Oh, bring that down a little bit. Okay. So again, we're going from 10 to 13. So A equals 10, B equals 13. So x, has a width of 3, which hasn't changed. And again, if you had it down to just one rectangle, for the area equals length times width to be true, and again, you know your area, remember that's the area of your 6x squared plus 5. For that to be true, and you have a width of 3, your length would have to be 5. Okay, your length, y equals f of x, would have to equal 5.
So you pretty much took that and divided it by 3 for 15.
Yep, exactly.
Same with the 9 earlier, you took the 9 and divided by 3.
Yep, that's it. Okay, so all we did was make sure our area was equal to, in this case, 15. Before, the area was equal to 9. Okay, so that means that our integral, because remember, that's your f of x. So you have the integral from 10 to 13 of 5 with respect to x is equal to 15. Okay. So there's actually another way you could do it if you wanted to. You could say that 6x squared plus 5 is greater than or equal to 5 when you're looking at 10 to 13. Okay, just on that interval. Okay, which means that the integral of 6x squared plus 5 from 10 to 13 is actually greater than or equal to the integral from 10 to 13 of 5 with respect to x. Okay, since this is our g, that's greater than or equal to our integral here, which we showed is 15. Okay. So remember, if we have one rectangle and that area is 15, when we have that all that missing space, it's only going to get bigger. Okay, so your area is going to grow from there. So it's going to be greater than or equal to 15.
It's true.
Yep, so this one's true. All right, so any questions on that one? All right. Good. All right, anyone still writing? Okay. Okay, so now we're going to go over the fundamental theorem of calculus.
Anytime there's a fun in there, you know it's not gonna be.
Actually, this just takes away all of the work of doing the limits and the summation and everything else to solve.
Cheat code?
Pretty much.
Oh.
Just a shortcut. Kind of like you didn't have to do limits anymore to find the derivative. This is the integral version of that. Okay, so if we have some function f of x is continuous over some interval from a to b, and we'll let the uppercase f of x represent our integral. Well, not and, but the antiderivative. Then the integral from a to b of f of x with respect to x is equal to the integral when you plug in b minus the integral when you plug in a.
Beforehand, like, how do we use to solve integrals?
No, that's when you had to do the summation and the delta x, and you had to exchange the summation for the n times n plus
Basically
1.
what we did last class.
Yeah, exactly. Yeah.
Oh,
So that's what we had to do before this, but this is just a lot shorter.
I thought we had to take the antiderivative last class or something.
I
Well, we did
think-
definite derivatives using the limit definition. Well, the definition of the definite integral. I had to remember the name of it.
Oh.
This is just the fundamental theorem, which is kind of a shortcut to the definition of the definite integral.
Yeah.
All right, so let's say, for example, we wanted to solve the integral from -3 to -1 of x to the fourth with respect to x. Okay, so you just integrate that like you normally would. So from -3 to -1 of x to the fourth with respect to x, that's just equal to x to the 4 plus 1 over 4 plus 1. But that's going to be from -3 to -1. Okay.
Yeah, how do you get the 4 plus 1?
Oh, because the integral formula, the integral of x to the n with respect to x is x to the n plus 1 over n plus 1.
Oh, okay. Forgot about that.
All right, so we know from here, we have x to the 5th power over 5 from -3 to -1. Okay, so first we plug in our -1, because remember it's f of b. So you have -1 to the 5th over 5 minus your integral when you plug in a. So it's -3 to the 5th over 5. Okay, so it ends up being negative 1 to the 5th is negative 1 over 5. Oh, move that up a little bit. Minus negative 3 to the 5th is negative 243 over 5. Negative and negative is positive, so you end up with 242 over 5. Okay, so no limits, no summation formulas, just straight through. Now, to say you won't have definite integral definition problems on the test. So you still have to know both. Oh, and I uploaded a copy of the review final review on Canvas.
You have one more test before the final?
Yep, one more test before the final.
Do you know if it's going to be Scantron or is it
Yep, it's Scantron, but no calculator.
okay.
Yep. But it is multiple choice, so.
I would use a calculator.
They give you an inch, then they take a foot. So.
Which is that can help you simplify.
All right, so let's say, for example, want to integrate from negative 3 to negative 1, t to the third plus 6t squared plus 9t plus 9 with respect to t. Okay, so now we're just going to integrate each one of those separately. Make sure that goes through. Okay, so we have, I'll just rewrite it. T cubed plus 6t squared plus 9t plus 9 with respect to t. You could distribute that to each one, but you don't really have to. You can just integrate them all together. Okay, so this becomes t to the 3 plus 1 over 3 plus 1 plus 6 times 2, a t to the 2 plus 1 over 2 plus 1 plus 9 times t to the, should have been 1 plus 1 over 1 plus 1. Because remember, t is just t to the first power. Plus 9t. And remember, that's from negative 3 to negative 1.
What's C? What's the constant?
Nope, actually you don't need a constant when doing definite integrals because you're subtracting one from the other. Let me give a quick example why. So if you have the integral from a to b of f of x, let's say you did put in the c. It would be f of b plus c minus, should be uppercase, f of a plus c.
Oh, so you're.
Yep, so those two just ends up canceling each other out, and f of b minus f of a. So you don't have to really worry about the plus c with definite integrals.
And that's because it has a range.
Hmm?
If you're doing an integral that didn't have a range at all, just doing the integral, then you have to put the plus c.
Yep, so if it didn't have that a and b, then you'd have to add the plus c. All right, so that's t to the 4th power over 4. So 1/4 t to the 4th plus t to the 3rd over 3. That's 6 and 3 just gives us 2 t to the 3rd plus 9 t squared over 2. We can just make that 9 over 2 t squared plus 9t from negative 3 to negative 1. Okay, so first we plug in our negative 1.